this series of Snap Circuits videos, we're going to look at projects 317 up to project 328. So, project 317 there is the mega circuit. There it is in the book. And there it is on the board. And like its name implies, it's a pretty big and complex circuit because there's a lot going on with it. We have our 7-segment LED display, which is being fed through our speaker and then grounded through our whistle chip. It's also connected over with our red LED D1. It's also got our green LED connecting into that from this, which then goes down into our PNP transistor. The base of the PNP transistor is connected across R4 and our power amplifier, which is being fed via our variable resistor, which also comes off of D3, the diode here, which is also going through resistor 3, and our 470 microfarad capacitor. And also I should mention our 10 microfarad capacitor is also coming across here from our two LEDs into our power amplifier. And then we can see the current going through this loop here through the 10 milliamps with our meter set to the low setting. So this essentially is a resonating circuit. It oscillates, and we'll see that with our flashing LEDs, and also our LED display will be flashing the number 5 because that's how it's configured with its connections here. And we'll also hear kind of a buzzing, chattering sound from the speaker, which is also being helped along with our whistle chip. So the variable resistor turned all the way to the top there. We turn it on. Our LED kind of glows up, and then our meter goes full deflection and winds back down as this capacitor charges up. And as we know, as the capacitor charges, its resistance increases. And if we can see here, I don't know how well the camera is pulling it up or how it's even going to show up on YouTube after conversion, but our red LED is flickering here, and so is the number 5. It is kind of blocked by the 3 snap wire across there. And our green LED kind of flickers a little bit too. Now we can adjust the rate of oscillation by adjusting the gain on our power amplifier using our variable resistor. So as we move this, the oscillation speeds up and it flickers faster. Now I don't know how well the audio from the speaker is coming up through the camera, so let me bring the speaker closely. So that's the ticking coming through our speaker, which is also being seen in our LEDs and helped out by the whistle chip. Bring the cable out. And of course we can go all the way over, and we get another burst of deflection on our meter there as current's diverted from our capacitor there. And now we get a kind of a continuous tone from the speaker because now the circuit is oscillating at a very high frequency, so it pretty much looks like everything is constant. And then of course we can take the variable resistor, go back the other way, and start changing that oscillation frequency. And again, depending how fast we make the change, we can adjust that capacitor charge-discharge rate too. So that is how Project 17 works. Now we're going to move on to Project 318 and start making use of our SCR, or Silicon Controlled Rectifier. So here we are with project number 318, the SCR 2.5 volt bulb. There it is in the book, and here it is on the board. And this time we're making use of our SCR, our Silicon Controlled Rectifier. So we've got 2 battery packs, but they're operating independently. our 3-volt pack here is powering the 2.5 volt lamp connected across our SCR, while our other 3-volt pack here is connected through a press switch in our 1000 ohm resistor to the gate of the SCR, and that one operates the SCR's trigger, while this one provides again the power for our lamp. So when we turn on the slide switch, nothing happens because the SCR has not been triggered to turn on. Now if we come over here and press our press switch, you notice that our 2.5 volt lamp lights, and it's staying lit. It doesn't matter how many times I press this press switch after it's been lit up. The SCR, once it's been triggered, keeps the loop here constant. So when it's triggered, the output stays on until the source power is turned off, in case which is our slide switch. So once the main power has been reset, then the SCR turns off, and then we can repeat it again after we turn it back on. So that is how project number 318 works. Now project 319 is our SCR and motor. So here we have project 319, the SCR and motor. Here it is in the book, and here it is on the board. And much like the previous project where we were using our 2.5 volt lamp, well, now we're using the SCR to control our motor. So again, we turn on the slide switch and nothing happens because the SCR hasn't been triggered. I'll come over here to our press switch. And we press it, and now our motor starts up, and it stays running as long as that SCR is allowing current to pass through it. And again, you can press the press switch all you want after it's been triggered, and it's not going to make any difference. Not only until we turn the power off and back on does it reset the SCR. So that is how project 319 works. So now we can move on to project 320. Well, here we are, project 320, the music alarm. There it is in the book, and here it is on the board. And instead of the red jumper wire, I just put a number 4 snap across here to simulate that connection. So we get our music IC that feeds output to our speaker, and its input, as you see, is controlled via our SCR, and its gate comes off of our number 3 resistor. Now it's being shorted to ground by our number 4 snap here. So if we take this away, then it's going to flow into the gate, and that will trigger our SCR, allowing our music IC to come on, and it will repeat because we have the hold function on the music IC enabled. So when we break the connection, the SCR turns on, and the music IC starts playing, and the connection stays constant. Now, project 321 is a variation of this, which is the light music alarm. So we keep our short off of there, and we put our photoresistor across it, and we keep it covered up. Now, I'll find out if I've got enough covering on this photoresistor or not. And I do. So, as long as the photoresistor is kept covered up, not enough light enters it to activate the gate of our SCR and turn our SCR on. Now, if I remove my finger, I should get enough. See, I just had to point it up at the light coming down, and that triggered our SCR. And we can do it again. That's how it works. Now, there's not enough light coming in at its angle. That's why I have to tip it up, otherwise the SCR would make sure that it stays current. So that's how project 320 and 321 are. Now we're going to look at project 322, which is the light-controlled SCR. So here we have project number 322, the light-controlled SCR. There it is in the book, and here it is on the board. And The SCR here is being used to control the power through our motor and 6-volt lamp, which are connected in series, and our photoresistor helps control the gate on the SCR whether to trigger or not. We're also making use of another new element here, our S3 switch, which is our relay, and that is being turned on and off via our slide switch, which connects the contacts here, which then allows the connection to the batteries, which in case this is a low power adapter, to our SCR, which thereby turns the power on and off to this side of the circuit. And our little red LED here is just to come on and off to tell us that the circuit is powered up or not. So if we keep the photoresistor covered up and we flick the slide switch over, you hear the little electromagnet click in there, which has changed the connection over, so now we got power going to that side of the SCR, and we know our circuit's live because our red LED is lit up. But the SCR hasn't triggered yet because not enough light has entered the photoresistor because I'm keeping it covered up. As soon as I take my finger off, the photoresistor gets enough light in it, activates the SCR, and now we've got current flow through our 6-volt lamp and our electric motor, and again they're connected in series, which is why our little 6-volt lamp here is dim. Until I slow the motor down, of course. And no matter what covering up we do there, sort of affects it there, interestingly. But anyway, turn it off. It resets. So that is how project number 322 works. Now we're going to move on to project 323, which is the 3 milliamp meter. So here we are with project 323, the 3 milliamp meter. There it is in the book, and here it is on the board. And it's a very simple circuit. We just have our meter connected in parallel with our 100 ohm resistor, then in series with our 1000 ohm resistor. So we turn the circuit on, our meter deflects over, as long as we get it set to the low scale, to about 9 or so on the scale there. Not really much to the circuit, kind of just demonstrating how the meter works across its range there. Connection problem there. So that's how project 323 is. Now project 324 is our 0 to 3 volt voltmeter. So here with project 324, the 0 to 3 volt voltmeter. There it is in the book, and here it is on the board. And here we're essentially making use of the meter to read a voltage range from 0 to 3 volts. And we're using our variable resistor kind of as to calibrate it. So we'll use our little B6 battery adapter with the 3 volt setting, and we'll plug it in there. And then we'll adjust our variable resistor till we get full deflection. So right around there is good. So since this is coming off wall power, we can pretty much use that as a bench. So I can take that off, and then we can go use our rechargeable battery packs. So that one's reading about 9, so the batteries have a pretty good charge on that pack. This one might be the lower one because I know one of these sets is not charged as much as the other. And actually that one is reading pretty good too. So they're both reading pretty good, but they still read a little bit lower voltage than the B6 adapter, and that makes sense because these are rechargeable batteries, so their nominal voltage is 1.2 volts per cell. So essentially it's more like 2.4 volts coming out versus the regulated 3 volts coming out of our B6 adapter. So that's how project number 324 works. So now we're going to work at project 325, the function of adjustable resistor. Here we are with project 325, the function of adjustable resistor. There it is in the book, and there it is on board. And essentially, we're using our meter to show the operation of the variable resistor with our 10,000 ohm resistor as our fixed amount. So we've got our variable resistor set all the way up, so that's our lowest amount, and we've got about maybe 1 on the deflection. And as we decrease the resistance on the variable resistor as we bring it down toward the bottom, more and more current starts flowing through the meter, and it deflects more and more to the right. So just a little bit past halfway, we're at the 5 mark on our meter. We keep on going. More current goes through it until we get to the very bottom, and we basically max the meter out at 10. So as we move the slider on our adjustable resistor, we can lower or increase the resistance as we move the slider, and so we get less or more current through our meter, so we get less or more deflection. So that's how Project 325 works. Now Project 326 is the function of photoresistor. So here we are with project number 326, the function of photoresistor. There it is in the book, and here it is on the board. And like the previous project, we're showing the function this time using the photoresistor and our meter acting as an ammeter to show the current change as more or less light enters our photoresistor. So we got a little bit of light entering the photoresistor now from our light source, which is over there. And we're kind of near 1. Of course, if I cover the photoresistor up, the meter completely deflects below 0. Let some of that light back in, it comes back up. And as I tilt it toward the light source, you see the meter deflects more to the right. And if I keep lifting this, you can see we get it around 4 or so. And if I had a light that I could shine directly on it, I'm sure the meter would go full deflection. So that kind of shows how Project 326 works. Now Project 327 is meter deflect by motor. So here is project number 327, the meter deflect by motor, excuse me. There it is in the book. And on the board, I kind of just simplified it using 3 snap wires instead of using the extra ones just to have the motor off to the side here. But we have our meter connected up as a ammeter across our motor here. And as we spin the motor, you see that our needle deflects to the right there. And I should note that the motor's orientation has the positive matching the positive over here on our meter. So as I turn the motor clockwise, it deflects the meter to the right. Now if I start deflecting this counterclockwise on the motor, well, it's actually going the other direction on the meter. Because as long as the current is flowing this way, positive, around that loop, the meter deflects this way. If we reverse that current, well, then the meter deflects in the other direction. And of course, the simple way would just be to swap the motor polarity around, so that if I was rotating the motor counterclockwise, well, then you would see the meter deflect the other way. So that's how project 327 works. And the last project is 328, and that's our SCR 6-volt bulb. So here we are with the SCR 6-volt bulb, project number 328. Here it is in the book, and here it is on the board. And like the SCR 2.5-volt bulb, this time we're using our L2 6-volt lamp with 6-volt power. And it's kind of controlled the same way with our 1000 ohm resistor via our press switch. And of course our slide switch controlling power for the whole circuit to reset the SCR. So when we turn the switch on, of course nothing happens. Our 6-volt lamp doesn't light up because the SCR hasn't been triggered. Press our press switch, we energize the gate on the SCR, turning the SCR on, and it allows current to pass through our 6-volt lamp, lighting it up. And of course once the SCR is triggered, it stays on, regardless if the gate is triggered again by pressing the press switch, until we reset it by turning off the main power and turning it back on. In which case we can of course trigger it again. So that is how project number 328 works, and that it concludes this set of Snap Circuits videos.